Module 10, Part 3, Newton's third law of motion. Well, I've discussed 2 of Newton's laws of motion, so there is only one more to go. It can be stated as follows. Newton's third law. For every action, there is an equal and opposite reaction. You've probably heard that before. However, I need to make sure that you understand exactly what it means. Perform the following experiment to find out. Experiment 10.4, Newton's third law. What happened in the experiment? When the baking soda mixed with the vinegar, a chemical reaction took place. The sodium bicarbonate in the baking soda reacted with the acetic acid in the vinegar. One of the products of that reaction is carbon dioxide, which is a gas. As the carbon dioxide gas formed, it filled up the bottle. Eventually, so much gas was formed that the bottle became pressurized. This exerted an enormous force in the stopper. Eventually, that force was great enough to push the stopper right out of the bottle. What happened as a result? The bottle started moving in the opposite direction. What you saw was Newton's third law in action. The gas exerted a force, an action, on the stopper. In response, the stopper exerted a force, a reaction, on the gas. Newton's third law states that these 2 forces are equal in strength but opposite in direction. Thus, the gas pushed the stopper in one direction and the stopper pushed the gas with the same strength but in the other direction. As a result, the stopper flew off in one direction and the bottle, which contained the gas, flew off in the opposite direction. The action in Newton's third law of motion really refers to a force. Thus, Newton's third law says that every time a force is applied to an object, an equal but opposite force is applied by that object to something else. In your experiment, the gas applied a force to the stopper. In response, the stopper applied an equal but opposite force to the gas. Just to make sure you understand this principle, let me give you one more example in the form of a figure. Figure 10.5, a young lady on a trampoline. Why does the trampoline allow this young lady to travel upward against the pull of gravity? Well, when she jumps on the trampoline, she exerts a force on it. If you were watching that happen, you would see the trampoline surface bend in response to the force. What does Newton's third law say will happen as a result? It says that the trampoline will exert an equal but opposite force on her. You know this happens because once she hits the trampoline, she slows down, stops, and then starts moving up into the air. Thus, her velocity changes. According to Newton's first law of motion, that cannot happen unless a force acts on her. What force was that? It was the equal and opposite force demanded by Newton's third law. In other words, she exerted a force on the trampoline, causing the surface to bow, and the trampoline exerted a force right back on her, causing her to accelerate in a different direction. The force the trampoline exerted on her was equal in strength to the force she exerted on the trampoline. It is very important to realize that the equal and opposite forces talked about in Newton's third law do not act on the same object. If that were the case, there would never be any acceleration. After all, if equal and opposite forces act on the same object, they cancel each other out and the resulting force is 0. Instead, the equal and opposite forces discussed in Newton's third law affect different objects. In the experiment, the gas exerted a force on the stopper. The equal and opposite force was exerted not on the stopper, but on the gas. Thus, the forces acted on 2 completely different objects. As a result, both objects ended up moving. In the trampoline, the young lady exerted a force on the trampoline, causing it to bend. The trampoline then exerted an equal and opposite force on her, accelerating her upward. Once again, the 2 forces worked on 2 different things. One force worked on the trampoline, the other on the young lady. Both things moved since the forces did not cancel because they acted on different things. Newton's third law of motion explains a lot of things that happen to us. For example, have you ever fired a gun? When you fire a gun, it kicks back toward you. People who shoot guns for the first time are often surprised by this effect. In fact, there have been cases in which novices were injured because they fired a gun and were not expecting the kick. What causes the gun's kick? Well, when you pull the trigger, you cause a chemical reaction to take place in the chamber. That reaction produces a lot of heat and gas. The gas is under pressure, so it exerts a force on the bullet, pushing the bullet out at an amazing speed. In response, the bullet pushes back against the gas in the gun. That's what causes the kick. Newton's third law of motion also explains how rockets fly. When a rocket or missile is launched, its fuel begins burning. As the fuel burns, it produces hot gas in great volumes. The pressure caused by the gas being formed pushes the gas out of the rocket. In response, the gas being pushed out pushes back on the rocket, causing the rocket to move in the opposite direction. This force is often called the thrust of the rocket. Thus, a rocket flies because gases are constantly being shoved out of the nozzles at its bottom. The equal and opposite force required by Newton's third law pushes the rocket in the opposite direction. Make sure you really understand Newton's third law of motion by answering the following on your own problems. On your own, 10.9. A tennis player hits a ball with her racket. The ball was traveling towards the player, but once she hits it with the racket, the ball begins traveling in the opposite direction. During the hit, the strings on the racket bow. I think they bow. What evidence do you have that the racket exerted a force on the ball? What applied the equal and opposite reaction as required by Newton's third law, and where was the force applied? What evidence do you have for this force? 10.2. An ice skater stands on the ice in his skates. He is holding a ball. Assuming that friction is so small it can be ignored, what will happen to the ice skater if he suddenly throws the ball hard to the west? In this module, you learned about the laws that govern motion. Despite the fact that they were discovered long ago, they still guide physics as the main laws that govern how objects move. Notice that each law deals with force. Although we intuitively know what a force is, in the next module, you will learn about where forces come from. You have the answers to the on your own questions on page 290 and 291 and 292. And then the study guide for module 10. And you are done.